All right, ladies and gentlemen, before we move into notes 4.3, I want to take a minute to review some information. I want to remind you that discrete graphs or discrete functions are things that we count. And the graphs often have individual points, whereas a continuous graph are things that we measure. And these graphs have lines. So it might be 2 points that are connected. It might be something that looks like that. But in some way, the points are connected. I also want to remind you that domain are the x values and range are the y values. So when we take a look at problem number 1 on your notes, what you're going to notice is that we've already filled in the domain and range for you. I want you to look at that graph right now and tell me, is it continuous or discrete? Continuous or discrete? Go ahead and say it, please. That's correct. It's discrete. Now we know it's discrete because of how it's been written. Then we have points that are not connected. Now, if I wanted to know the domain, I need the coordinates of each point. So I have -8, -7. This is -5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. And then -1, 2. This one is 4, 0. And this one is 8, -1, 2, 3, 4, 5, -5. So if I wanted to find the domain of all of these, since you know the domain is the x values, then I would simply list every x value for the points. So I have them listed right here. Now they don't have to go in order. Math teachers tend to write them in order. But what you can't do is you can't have anything that's repeated. So you don't write a repeated number. The range is the y values. So I simply take the y values and write them here. When I'm taking a look at example 2, now in your class you're going to be using a post-it note, but for here I'm going to be looking at it with just lines, okay? So the first thing I'm going to do is I'm going to deal with the domain, which is the x values, and I draw a line going through the x-axis. And that helps me see that the smallest x is at 2. If you look right here, that's my smallest x value is 2. And my largest my smallest x value is at -8. And my largest x value is at 2. And I can see that the graph is located between these two lines. So that tells me that all of the x values are located between -8 and 2. And I know it's going to be less than. As long as you put your lowest x value on the left, it will always be this model of less than, less than. I look at the points, I see that that is a filled in point. I look at this one and I see that is a filled in point. So I know I'm going to have an underline underneath each one. Now that took care of the domain, but I still need to look at the range. The range is my y value, so I draw a line going through my y-axis. And I can see that the lowest y value used is -4, and the highest y value used is 1. So I know my y's are greater than -4 and less than 1. And again, because it's a filled in circle, I do an underline. Now for me, this is easier with a post-it note than it is drawing the line, but some people drawing the line is enough. It's really up to you on what you need to use. Now let's take a look at number 3. I'm going to start by doing the domain, which is my x values. So I start by drawing a line through the x values. Now you don't necessarily have to draw the line as long as you can see it. And I notice that 1, 2, 3, 4, 4 is my highest x. 1, 2, 3, 4, 5, 6. Negative 6 is my lowest x value. So I know x is going to be between negative 6 and 4. I know it's going to be less than or less than. I just have to decide if I need the underline underneath it. So I look here at the point where negative 6 is, and it's an open circle. So I know there's no underline underneath this inequality. But when I look at the 4, I can see that the circle is closed. So I know I need to put an underline underneath that inequality where the 4 is located. I'm going to take a look at the range. When I look at the range is my y values. So I'll draw a line going through my y-axis. And I see that my highest y value is 1, 2, 3, 4, 5, 6, positive 6. And my lowest y value is at negative 2. So I know my y is going to be between negative 2 and 6. I look at the circle on the negative 2 and it's open. I look at the circle on the 6 and it's closed. So I draw an underline underneath it because it's equal to. I want you to pause the video and try to do number 4 without me. Try to do number 4 before I work it, and then restart the video. That'll give you a practice. All right, if domain is my x values, then I know it goes from 1, 2, 3, 4, 5. 5 is my high, negative 3 is my low. So I know my domain is negative 3 is less than x, which is less than 5. My range is my y values, and that goes from negative 1 to 3, and that's y, and those are going to be less than and less than. I always want to write the lowest number on the left and the highest number on the right when I'm writing these inequalities, and if I do that, then my inequalities will both be less than. Number 5. The function f is graphed below. So here's my function f. They've graphed it for me. I know it's a function because if I do the vertical line test, it only hits one time. I also know that it's a function because they said it. It says, what is the range of f? So this is f, and they want to know what is the range. Well, range is y values. So that means my answers would be A and B. Do you see why those are my answers? Look at what it's dealing with. Do you see that it's dealing with x's? Well, x's is domain, and they've told us to do the range, so it can't be A or B. It has to be C or D. So whenever you're dealing with multiple choice, I want you to make sure that you're eliminating your answers first. Now, if I take a look at my f, and I want to do the range, then I'm going to draw back to my y. I'm sorry, that's not y. Which axis is that? Yep, I apologize. I'm going to draw back to my y, and I see that my lowest y is at negative 3, and my highest y is at positive 3. Now I need to look at those circles because that's where they're trying to mess me up. If you notice, at the 3, this is an open circle. That means where the positive 3 is located, I can't have an underline. So the answer has to be D. Taking a look at problem number 6. Well, this one's going to look a little different. You can see that it goes on forever because it has this arrow here. So I don't have an endpoint like I did on the other graphs. So that's okay. I know my domain is my x, so I draw my line to the x-axis, and I can see that it's at negative 3. But I also see that it uses all of my x values going that way, and I know that because that's the way the graph is going. So if I were to look at my y's, then I can see my y is here at 2, and it's using everything below it. So there's a couple of ways to look at it. The first way is to say, okay, this is -3, so I know it's x and -3, and it uses everything to the right, which would be bigger than, so it's got to be greater than or equal to. The other way to look at it is to pick the point out here. This is 10. Is 10 bigger than -3? The answer is yes, so you would do greater than. Now for the range, that's my y values. Oh, I did red a minute ago. That's my y values. I see that it's 2 and it's using everything below it. The other way, my y value is 2. The other way to look at it is pick a point. That's at 10, -10. And I can see that that y value is less than 2. So y has to be less than or equal to 2. So there's a couple of ways to look at it. Number 7. I want you to go ahead and try this without me and see how you do. Try number 7 and see how you do. Pause the video and then start it again. All right, I'm going to start with my domain. I know that the coordinates of this point are 1, 2, 3, 4, 5, -2. And if I start with the domain, that's my x values. I notice that my x is at 5, and I could pick this point right here, right? And that's 1, 2, 3, 4, -4, 5. And I could say 5 and -4, so I know x is less than 5. The other way to look at it is, here's where it crosses the x-axis. My graph is that way, so it has to be x is less than, because those numbers are getting smaller, because out here is -10 on the x-axis. I don't like the way that's messy, so I'm going to go fix that. Now, taking a look at my y values. My y value is -2. Draw a line going back to the y-axis. It's at -2, and I can see I'm using the y values above that line. So y is greater than -2. The other way to look at it is to pick this point out here, -4, 5. Look at the y. Is that 5 bigger than -2? The answer is yes, so y has to be getting bigger. So number 8 is really kind of a tricky question, and we've actually seen it on the EOC before, so we want to make sure that we're taking some time to review it. So it says, which graph shows a function with a domain of all real numbers that are greater than 7? So domain is my x values, so we're looking for something where x is greater than 7. So if I'm looking for x is greater than 7, then I'm going to look at my x-axis. I see that's at 7, and I see that it's shading to the right, so x is greater than 7. That appears to be right, but I'm going to go look at each answer choice just to be safe. If I look at my x values, this is at 0, and this is x is greater than 0. If I look at D, my x values are at 7, but they're all at 7. If I choose this point, it's 7, right? Like this point is 7, 7. This point is 7, 8. This point is 7, 9. This point is 7, 10. I'm making up stuff because I can't really see that graph, but my point is all the x values are 7. So it's not D, which means it's not going to be Y either, because all of these x values are going to be 7. This is 7, -1, 7, -2, 7, -3, etc. So it has to be A. A is my answer choice. All right, that's all we have for you today is domain and range of functions. Make sure that you work on the homework and make sure you take care of getting your homework done and turned in. All right, thank you for watching videos. We know that students that take time to watch the videos either before class or to watch videos when they're absent, do better in classes, and we're grateful that you are putting the time in to do that.